Hello all, let's start chapter 3. Chapter 3, 3.1, 3.2 is about measures of center. Uh, if I draw here a graph for you, something like this maybe, correct? We call usually this one a normal distribution graph. Later in the next chapter or next, you will understand a lot about this graph. But right now, I graphed it because I want to explain where is the center of the data. The center of the data is actually located here. Remember, the example that we did in the class about your ages, most of the ages of the class was 17 to 21, I think, that day, right? Most of the data, which was allowed 25 people, they were located like in the center of the data. We had some ages on this side and some ages on this side. Not actually this side, only on the right side, greater than 22 years, but most of the ages in the class were like around 25 of them was here. This is what we call here the center of the data. Now, center of a data can be measured, and there are 5 main characteristics that actually explain the center of a data. Correct? There are 5 characteristics that explains the center of a data. Number 1 is center. Correct? Number 2 is variation. Number 3 is distribution. Number 4, outliers. Number 5, change over time. Now, in this chapter, we study these 5 characteristics one by one. Let's start with the first one, which is center. Number 1, center. Center, what does it mean? I already explained to you. The middle of your data set. The middle of data set, we call it center. Correct? There are 3 ways to measure the center. There are 3 ways that you can measure the center of a data set. The first one, we call it mean. Most of us, we are familiar with the terms mean or with the word mean. Mean is actually arithmetic average. When I'm using the word average, most of you have an idea how to find the average between few given numbers. Correct? For example, if I give you 25, 60, 35, and I ask you to find the mean or the average of these three numbers, immediately you say, oh sir, we will add these three numbers and we divide, because we have three numbers, divide by 3, it gives us the average. Yes, correct. This is the way that you find the mean, correct? Then based on this example, let's create a formula. Even before that, I can write for you, add all the values, add all the values, and divide by the number of values, by the number of values you added. Okay, this way you can find the mean. To start to create a formula, I will just translate this English sentence somehow to a mathematical language. Somehow, not perfectly, but later we will change everything to a mathematical notation. I can say mean equals all the values, or I can say the sum of all the values, the sum of all values. Over means divide, right? Over number of values. Now, let's slowly change it to mathematical notation. Mean equals sum of values. We already know the sign. We explained it. We used it before. Sigma means sum, correct? Then the sum of values. Values, we are using always a variable for values, and the famous variable in mathematics is always x, right? Then your x represents what? Value, correct? The sum of value over number of values. You may ask me why you don't put a notation for denominator. Before putting a notation for your denominator, I want to give you some more small notes here, or some notations that you should know. Okay, the first one, sum. Sigma means sum. X, values, correct? Now, n, you can use lowercase n for the number of values, but if you are dealing with a sample, if you want to find the mean of a sample, if you want to find the mean of population, then use capital N. Capital N means number of values. And also I need a notation for mean, for actual mean. Again, when you are dealing with sample, the notation for mean is x bar. X, a dash in the top of the x, we call it x bar. X bar means mean of a sample. If you are dealing with population, use this Greek letter, which we call it mu. Mu is the mean of a population. Now, using all these notation, I can say, if I'm dealing with sample, if I want to find the mean of a sample, then x bar equals sum of the x over lowercase n. If I'm dealing with population, if I want to find the mean of a population, then I will write mu equals sum of the x, sum of your data, over capital N, which is the number of values. Formulas are totally the same. Your calculation will be totally the same. Only your notation is changing. It's not two formulas. Well, somehow it's two formulas because in one of them you show the population and one of them you show the sample. But the calculation, in terms of doing it, in terms of the operation, they are totally the same. Why we use two notation? Because when we present our results to someone, if you use x bar, for example, if I give you a problem and you write x bar equal to, immediately because I know it, I know you are talking about the mean of a sample. And if I see mu equals to, I will say, oh, he or she is talking about mean of a population, right? Then these two formulas, x bar equal sum of x over n and mu equals sum of x over uppercase N. These are the formulas to find the mean of a data set. Correct? Now, let's do an example. Example number 1. Find the mean of a sample two, 3, 5, 1, 7. Correct? They are asking you to find the mean of this data set, but they use the word sample. Immediately, by reading this, I know I will use my x bar formula. X bar equals sum of the x's over lowercase n, which means sum of the x's, it means 2. Each one of them is a x, right? This is your data value. 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 Each one of them is an x, right? Then the sum of them, 2 plus 3 plus 5 plus 1 plus 7, divide by n. How many data I have? 1, 2, 3, 4, 5. Divide by 5. Which will give me 8, 10, 18 over 5, and if you simplify, it gives you 3.6, I think. 3.6. This one will be the sum of the mean of a given sample, correct? Let's see if I have another example. I will put few more numbers, but I want you to remember this example because we will use this example for the next part also. Example number 2. In example number 2, it's given 3, 4, 5. It's again a sample. 5, 6, 8, 11, 13, and 412. Correct? I want to find the mean of this. Then x bar equals the sum of these values. 3 plus 4 plus 5 plus 6 plus 8 plus 11 plus 13 plus 412 over number of these 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. then x bar equals 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18, 18 plus 8, 26, 26 plus 11, 37, 37 plus 13, 50, 50 plus 412 gives you 462. Hopefully I'm right. If I miscalculated, you can correct me, because I'm not using a calculator. Now I need to use a calculator. 462 divided by 8. Let me bring up my calculator. 462 divided by 8, which gives me 57.75. 57.75, that will be the mean of this data. Look at here. Actually, if you focus a little bit, if you focus in my lecture what I'm talking about, and try to learn the concept. Look, if I remove 412, correct? The rest of the data, they're really close to each other. 3, 4, 5, 6, 8, 11, 13. They're really close to each other. If I want to graph it, I can show you like this. Most of your data, like 3, 4, 5, 6, 8, 11, 13, they're lying here. It's here, all of them. But you see 412 is somewhere here, too far from this data, correct? That's why sometimes it's not good to just find the mean of a data set, because it doesn't make sense sometimes. It cannot explain anything to you, because it's like, look at the mean. If I just change this 412 to 12, the mean will change really a lot, right? If I just change 412 to 12, you will see the mean will go down really a lot, by a lot, right? But because of one number, it lies like too far from the center, correct? A real example in real life is, look at, if I wanna compare like the most of the people in United States, their salaries, with someone like maybe Bill Gates or Bill Gates. If you want to find the average, the mean, and you calculate also how much he is making per year and how much is a normal person is making per year, he is making millions, billions per year. A normal person, we are making thousands, right? Finding the mean to describe, oh, average people in the United States is making this much money, it will be useless if I calculate his salary. That's why we have another way that we can measure the center of a data, and we call it what? Median. Correct? If we have a set of data, for example, let's say 4, 3, 7, 9, 2, 1. You can find the median. Correct? What is the median of these numbers? How we can find the median? Few things that you have to memorize or you have to remember. Number one, your data set must be in order. First, you have to order your data set. Look here, I have 4, 3, 7, then 9, then 2, then 1. First, you have to order them like this. 1, 2, 3, 4, 7, 9. You have to order it first. Now, what you do after this, find the middle value. Find the middle value. To find the middle value, there are two cases. You see, my data set here is actually 6 data. 1, 2, 3, 4, 5, 6 of them. Maybe I have a data set like this. 1, 2, 3, 4, 5, 7, 9. Here I have 7 of them. Your data that you have in a set, your set can be odd numbers or it can have even numbers in it. Then there are two cases here. If you deal with an odd number of data, how to find the median, and if you deal with the even number of data, how to deal with. Case number 1. If the number of values, even I'm writing for you, if the number of values are odd, the median is the middle number. For example, in the data set which is in red color, I have 1, 2, 3, 4, 5, 7, 9. It's an odd number, right? Where is the median? 4 is the median. You see 3 on this side, 3 on this side, then 4 is the median. That's why you have to order also your data. Because what? If I don't order, if it was 9 there, is 9 the median between these numbers? No. That's why I told you first order your data. Case number 2. If the number of values are even, add two middle values, add two middle values and divide by 2. It sounds for you really familiar what I'm asking here. And divide by 2. Actually, you're looking here for average, or even you can say you're looking for the mean, right? The mean between the two middle number. The first data set, which was 1, 2, 3, 5. We don't have 5 actually, we had 4 here. The first one was 4, 7, 9. You see the number of values are even. 1, 2, 3, 4, 4, 7, 9. It's 6 of them, correct? What I'll do, I'll take these two numbers, the middle one. I will add them, 3 plus 4, and I'll divide it by 2, which gives me 7 over 2, which means what? 3.5. Then the median for this example is 3.5. Correct? Now, the example that I did here with 412, correct? Let's see. Let's rewrite this example. 3, 4, 5, 6, 8. Let me find the example here if I have it. I will copy it again. Here. I can copy it. Let's do this example and find the median for it. Example. We had 3, 4, 5, 6, 8, 11, 13, and 412. To find the median, is this data set is even or odd? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. It's even, then I'll add the two middle number. But remember, my data set is in order. It's already in order. Correct? If it's not in order, please order it first. But it's already in order. The two middle numbers are 6 and 8. I will add them and I will divide it by 2, which gives me 14 divided by 2, which is 7. You see, the mean is 7. The median is 7. Even if I change 412 to 12, the median will not change. The median will not change. Or let's say change it to, let's say 14, correct? To be in nice order. If I change it even to 14, the median will not change. But if I look for the mean, if this number is 412, we had 50 point something, right? Our mean was 57.75. But if I change it to 14, the mean immediately goes down too, correct? Then from here, I want to give you some notes, correct? Or a small note here that you have to remember. The median is not affected by outliers. You see, 412 is an outlier. Here even I show it in a graph. I try to sketch something to show it for you. Your 412 is an outlier. It's too far from the rest of the data. But you see here, the median is not affected by that outlier. Correct? The mean is, I will just write the mean as you know how to complete this sentence. The mean is affected by the outliers, but the median not. That's why usually when we talk about kind of comparing or finding the center, when we talk about salaries that I give you an example, or about the house's price, correct? Usually they're talking about the median, not mean. They are using median, not mean, because by some outliers, mean can be changed, but outliers doesn't affect median, correct? Last part of the lecture, the third one is, let's talk the last one also for you to finish this lecture. The last one is mod. Correct? The most, this is the definition, the most commonly the most commonly occurring data, we call it what? Or data value, we call it mod. Correct? Example number 1. How the most occurring in a data set. For example, 5.4, 1.1, 0.42, 0.73, let's say 0.48, and 1.1. The most occurring data. You see 1.1, 1.1. It occurs in your data set twice. Then the mode is what? 1.1. Correct? Let's see another example. Example 2. 27, 27, 27, 5, 5, 5, 87, 87, 89. What is the mode here? The most occurring one. 1, 2, 3. 27 occurred 3 times. Also 5 occurred 3 times. Then 5 and 27 are the mode. You may tell me, oh, 87 also occurred twice, but no. The most. You have 2 87s. If you had 3 of them, yes, it would be also a mode. The most. Correct? We call this one bimode because it's 2, correct? 2 of them. Let's see this example. 1, 2, 3, 5, 9, 10, 12. Do you have a number here that's repeating or occurring more than once? No. Then you can write no mode, or you can use this sign. Empty set or phi. There is no mode. Correct? One more thing about rounding rules, then I'll stop the lecture, but I'll make a second part for this 3.2. Rounding rules. 2 easy rules when you are rounding a number off. Number 1, or rule 1. Round 1 more than what they give you. What does it mean? For example, in this example, you see when you are finding this example, when you are finding the median of this data set, 1, 2, 3, 4, 5, what is given, they are all whole numbers, correct? When I end up the answer, I have 1 decimal place, 1 more than this, correct? To explain it well, if your data set is given like this, 2.1, 3.7, 5.8, for example, I don't know what is the mean here. If I want to find the mean, let's say the mean is something like 4.123. I will round it to 2 places like this. I'll keep it like this. 1 more than it's given. Here I have 1 decimal place. Here I have 2 decimal place. That's the rule 1 of rounding. Rule number 2, you can't, it's really important, you can't round until very last step. Up to now, we are dealing only with one formula, but soon you will see there are formulas that you first find mean, then you plug in your mean to another formula, and you find or you calculate something else. For example, if you find your mean as a 2.1679 and you round it to 2.17 and you plug in this one in another formula and you round it off again, your answer will be way off, and in statistics we cannot do that. That's why you are waiting for the last step and you only round in the last step. I'll stop the lecture and I'll make a part 2 of this video, and see you in part 2 of section 3.2.